In this section, we'll be looking at optimizing performance through indexing. Many times when our table gets bigger and we want to see performance boost, our query statements, which were performing fine with the smaller tables, now it starts to lag and it takes lots of time. In those cases, indexing is used. So an index is a database object that helps to speed up the search and retrieval of the data from a table. And by creating an index on one or more columns, the database engine can quickly locate and require rows and does not have to scan the entire table. And indexing internally uses algorithms such as a binary search, B-tree, zigzag algorithm, etc. to make optimizations based on the database engine that you are using. So they could be varying, but these are some common algorithms that they use. So as obviously known, indexing is used to perform the query optimizations and to perform the query in faster speed in the database. So indexing is good, but there are some situations where we have to avoid indexing, and in those situations, we should not be using indexing. So when our table is smaller, we should not be using indexing, and also tables that have a lot of batch updates and inserts should be avoided to do indexing, and columns that have lots of null and columns or attribute that are changed or manipulated frequently should not be used to index. In attributes which are not used in the query statement or conditions should also be avoided in the indexing operation. So in terms of the syntax, to create an index, we just use create index and then index name on table, and then you pass on the columns that you want to index on. So it could be one or more columns depending upon your index statement. So let's look at some of the examples. So first, querying a table before indexing and after indexing. So in this example, we'll just be getting a count on a product ID from orders table. So select customer ID, comma, count a product ID from orders and a group by customer ID, and we will order by customer ID ascending. So initially, without the indexing, it takes an 85 milliseconds, and in the example, it might take more or less than that. And after the indexing, we do create index order on orders and a customer ID and product ID. So we create an index on orders named as index IDX underscore orders, and this will be on the columns customer ID and product ID. And after indexing, running the same command will reduce the time by fewer milliseconds to 47 milliseconds in this example. So we'll also see that number of milliseconds might vary, but the idea is that initially if it was taking more milliseconds, then in the later phase it will take lesser. So sometimes we might have to reindex if our indexing is not efficient. So and also sometimes we might have to drop the index. So to reindex, we do reindex and then index keyword, and then we give the index name, in this case in idx underscore orders. And for dropping the index, we just use drop index command with index name at the end. So let's go ahead and see some hands-on example. So let's go ahead and then open up my PZ admin. So over here, I will be writing some query. Will be just counting the product ID and grouping by customer ID in the orders table. So we do. Sending. So let's go ahead and run this command. And sure enough, so over here at the end, we can see that query completed on 104. So it take around 104 milliseconds to run this. And then if we create an index using create index and idx underscore orders, and then on the orders table. So using the CSTRM customer ID, product ID, and then we create this index and then run it. Now create index has been successful. And if we run the same command over here, so it should take about 43 milliseconds. Previously it was taking 104 milliseconds. There is a significant boost on the performance over here using this over here around 43 milliseconds. So in this section, we look at the index and how to create an index. And also if you want to drop the index, you will do drop index and then the name of the index IDX_ORE orders. And then it should pretty much drop the index that we created right now. Yeah. So in this section, we saw indexing, and in the next section, we'll be seeing functions in SQL.